Welcome everyone to the lunchtime live session. My name is Stephen Majuri. I'm in the Forensic Investigative Analytics team based here in Belfast. I'm joined by Thomas, Vanilla, Natalie, and Stuart, and we're going to spend the next sort of 35 to 40 minutes or so talking about the use of technology and analytics to prevent and detect fraud in organizations. So let's kick off. Why are we going to talk about this? Why are we going to talk about fraud? So based on PwC's Global Economic Crime Survey, we've found that nearly half of companies surveyed, so that's over 7,000 companies, have suffered at least one instance of fraud over the last 2 years, with the average amount of fraudulent incidents being 6 per company. As you can see from the second point there, this isn't an insignificant number either. This amounts to an estimated £32 billion lost globally. So that's quite eye-watering, and that's taken directly out of the bottom line of these companies. The threat of fraud is real, and it will grow. And I mean, given the current climate at the minute with COVID, I wouldn't be surprised if we see the instances of reported fraud start to sort of almost skyrocket over the next couple of years, given the quantity of money that is being given out sort of kind of rapidly to businesses and individuals through the various grant and loan schemes that are going on at the minute. So I guess why I brought this up at the start is basically to say, ignore fraud in your company at your peril. Not mitigating these risks will and can be incredibly costly. So where does technology fit into this? So as companies start to grow and hold more data, and this is coming from more disparate sources, it becomes almost impossible to mitigate the risk of fraud without some sort of technology aid. I mean, I can't remember a single investigation that I've done in my career in PwC around fraud that didn't use some sort of technology or analytics to help us get to an answer for a client. So what did our survey say? So in terms of how companies use analytics, the Global Economic Crime Survey said, there's a positive trend towards technology. There's a majority of companies are using technology to monitor fraud, and the majority of companies agree that it provides actionable insight with regards to fraud, and nearly three quarters of the companies plan to use artificial intelligence going forward with regards to mitigating the risk of fraud. But there's one that I've highlighted here, which is sort of a contradiction to the other, and that's the cases of fraud that are actually being identified by analytics, and that has dropped over the last couple of years. So why do we think that is? I think number one, fraudsters are getting smarter as these schemes are coming to light, and the fraudsters sort of understand the controls are in place and can work within organizations. I mean, we know that 40% of fraud is caused by someone within an organization. But the other side of the coin, and the bit which is how we're framing this conversation today, is around maybe the effective use of the technology within the organization. So perhaps although the technology is there, it's not quite being augmented with the correct business logic, or maybe we're not using the most efficient tools or techniques to address a company's specific risk to fraud. So that's how we're going to reframe this conversation as we go on. So Thomas is going to kick off by talking about, I guess, what we'd call traditional fraud detection methods, so red flag tests. And these, I mean, we've used these in PwC, and companies use these and have done very successfully for decades, I would say. So he's going to talk about sort of the benefits and then some of the limitations there. Vanilla is then going to talk about how we sort of layer on top of that more visual analytics, more exploratory analytics, and how we then target and build out fraud scenarios, and also then how we can augment additional data sources to help our testing. Natalie then is going to talk about how we've brought these together and developed some what we would call digital assets, some tools and techniques that we use within PwC, as well as then some other software that we use from outside PwC to aid in our investigations. And Stuart's going to end then by talking about the sort of the future of analytics, so more around machine learning and artificial intelligence. So I hope you enjoy this talk and each of you takes at least something from it. And with that, I will hand over to Thomas.
Great, thank you, Stephen. Yep, so like Stephen mentioned, I'm going to be chatting through traditional fraud detection methods, mostly red flag testing. So when we think of analytics to detect fraud, the first step is generally identifying red flags. And we do this via red flag testing. And these tests, they're quick, easy, and they're cost effective. They require really no specialist software and can provide a really good starting sample of data to look over, as the majority of these tests can be done in tools, say like Excel or other widely used applications, maybe like Access. And they allow you to then export a list of, say, transactions and then run these tests on that data. And these red flag tests, I mean, they could be anything. They could be payments with a quick turnaround time, vendors only interacting with, say, one specific user, postings out of hours, payments just below authorization limits. I mean, there are so many. I could list them for days. And when we're doing these kind of investigations and these analytics, what we're really asking is, are these red flags actually suspicious? So the main issue that you find with red flag testing is they bring back a lot of noise. And what I mean by that is not all out of the ordinary behavior is suspicious. So for example, round sum amounts, they are common. People work late all the time. You know, data can be inaccurate. People can make mistakes. And another problem with this then is that you find that there's no gray area whenever it comes to red flag testing. They're binary. So it's either a yes or a no. And this then can lead to a problem whenever you're sifting through false positives and not really focusing in on a potential problem. But like I have said previously, they produce noise, but they can push you in the right direction. So for example, we were working alongside a fraud department for a large client, and we pulled out loads of out of hours transactions. And the client said, "Oh, okay, great, that's great, but this person here, they shouldn't have been working late." And he was then investigated further. So red flag testing told us that they were staying late, but not why they were staying late. And the why is just as important, and it is what we and the companies that we're investigating care about. And as the digital space around us grows, so does the potential for fraudulent activity. And these fraudsters, they can learn how to get around these basic checks that we're carrying out. So like put yourself in the shoes of the fraudster with even say like the slightest knowledge of finance control. If I was defrauding a company, I wouldn't be raising payments for £20,000 at 8 o'clock at night under my own name, because that's highly suspicious. So even just to talk about a few examples that we've had in projects that we've worked through at PwC, we had an investigation into a massive multinational global organization. And the allegation was in relation to bribery and corruption, and it came to us through regulators and whistleblowers. And the investigation was based off their entire ERP system, and it included a general ledger of more than 500 million transactions, which I'm sure you can imagine is a lot. So there's no possible way to sit down and review 500 million lines. That's too much. So to reduce the sample size, you use these common red flag tests that I talked about previously, say limiting on specific known names, location, details of even certain amounts. And that makes the data palatable. And then it allows for the rest of the team to do an even deeper dive onto what we believe to be the relevant data. Another example, I'm sure you've all heard of it, the News of the World phone hacking scandal. We were brought in to analyze and quantify payments, and then use the techniques that I've talked about before to look over another massive data set and try to identify the payments that have been then linked to bribery. And final example, we had an investigation brought to us by a whistleblower. It was about a head of finance siphoning money from a charity to fund their lavish lifestyle. And through the use of the tests that I talked about, we were able to identify that there were multiple ghost employees that had been set up, and that member of staff had been paying themselves well over 300,000 through these ghost employees. And so from what I've talked about, you can kind of see why businesses do require these red flag tests. Like I've said, they're cost effective, they're quick, they're easy, they can be carried out with no specialist software. But they only really give you the start to what an investigation can be, and more advanced techniques are needed. And that's the rest of the guys will be chatting about. So Fionnuala is going to take over for me and take you through one of these advanced techniques.
Yeah, thanks, Tom, for taking us through those red flag tests. So if we think about a typical project that we might do, what would be the first thing we do when we get data? We don't really just go straight into those red flag tests, but typically what we might do is try to visualize the data to get an understanding of it, because this can give us like a good exploratory view of the movement and show us where to focus. So if you look at this example, this is visualizing transactions over time in an area graph where the invoice type, you can see the different colors. And what you can see here, you can see the year-end reference line, is that typically seasonally, as is here, there might be a high amount of invoices just before year-end, so we might expect that. But what you can also see is just after year-end in the first 2 years, high amount of credits just after year end. So what this could potentially be is that the company might be inflating their data prior to year end and then crediting it after year end. So what they're doing is inflating their invoices and then for reporting and then crediting it. So what we potentially do is flag this to company and say this could be an issue and we might want to take a deeper dive into this. So again, it wouldn't be the full project, but it gives us a really good idea of where to look next. So another example of this is also in GL accounts. So this quite complicated diagram actually is the GL accounts in a financial system posted around the edges, and then the different journal transactions posted as the links between the different GL accounts. And what this can actually show, if, for example, if I showed this to a financial director of a company, is that there might be some GL accounts that they would expect to interact with each other, but there could also be other GL accounts that they wouldn't expect to interact with each other that in fact are. And again, this can really quickly derive some important insights into the data that if you were to give them spreadsheets, you would probably never be able to get that information out, certainly not as quickly or easily as you could by visualizing it. So generally when we do visualizations, they just point us kind of in the right direction, show us where to look. But another good example of this is this dormant vendor hijack fraud hypothesis. So this is where we kind of take the visualization information, but we go towards a more targeted scenario-based approach. So say, for example, if you are an employee of a company in the finance department, you've been there for years and you've noticed that there's a vendor who hasn't really posted a lot of transactions for a long time, and you think, oh, I can maybe do something with this. So you modify the bank account information to potentially your own, and then you start posting a lot of transactions after doing that. And they might be small transactions, they may not get flagged in the company. But what then we can do is we can say, okay, we have noticed that through potentially our red flag testing that no transactions long time, bank account information is modified, and then a lot of transactions are posted after that. So instead of those being 3 kind of red flag tests, we take this as one kind of scenario hypothesis test. So, and then we can look for other traces or patterns in systems that also resemble this. And not only that, but we can kind of also work with our colleagues in the investigations team to refine that approach and really reduce the noise and the false positives that come out of those tests that Tom was talking about earlier. So through working together, it's kind of an iterative approach. We have developed some of these fraud hypotheses, and then we can apply these to other scenarios and other financial data sets. And then the last kind of few slides, we're talking about financial data sets, but we also work with different data sets. And for example, the Project Rusky. So what Rusky was a whistleblower allegation into a utilities provider. And there was allegations of accepting cash in hand bribes to carry out work at locations basically where they shouldn't have been. So what you can see here is the dashboard, which we developed for Project Rusky. And you can see some examples of the tests that we carried out. So activating the PTO at unauthorized locations. When you see the word PTO there, this is basically our way of identifying where the work was being carried out at a certain location. And this is quite useful as we were able to take location and timestamp information from the PTO. So as you'll see shortly, we were able to use that in quite a useful way. We also kind of traced out of hours activity and a few other tests there. So if we want to look a bit more into activating the PTO at unauthorized locations, we'll go to the next dashboard. So this kind of traces those the PTO activation at different times. And as you can see, there's quite a high discrepancy there on the 24th of August. So just in red there, it's flagged as some discrepancies, and we're going to go into that a bit deeper and look at another level. And then this final dashboard shows us the actual map locations where the worker was carrying out work on the day that we've defined, so the 24th of August. And these green calendars are showing the actual legitimate locations where the worker was going to carry out the work. So you start to see here the tracing of the worker's GPS locations. You can see, okay, he's going to that legitimate location. But then these red circles which appear, those are discrepancy locations where the PTO, where they were carrying out work, was activated, but where they shouldn't have been. So we start to say, okay, why were they there? And again, there you can see tracing along multiple other activations of the PTO where they shouldn't have been. So what we can say is, okay, they've been to a few locations where they shouldn't have been. They've been carrying out work where they shouldn't have been. Why were they there? Okay, what does it look like? And then what you can actually do is go into Google Maps. So this, if we click on the discrepancy location, will take us straight to Google Maps. And this is very powerful because then you can see exactly where they are. You can put this in front of the client, and then they can ask, why was the worker there and what were they doing at this location? So you can see it's a random country road in the middle of nowhere. It seems a bit odd that they'd be carrying out work there. But what's powerful about this is that previously they were doing this manually, and it was taking them more than 1 year per vehicle to be able to do this, because if you think about it, you're putting GPS locations into Google, you don't really know what you're looking for. There's no legitimate locations in Google, so you have to figure it all out yourself. So being able to overlay the GPS information, the PTO information, the legitimate locations all in one map for the workers or for the client to be able to see this in one go, it really improved the efficiency of the whole process. So I think that was a few examples of times where we have made traditional testing a bit smarter. But now Nat's going to talk about how we have built these out even more.
Yeah, thanks, Anila. So over the past few years, we have both built our own tools and invested in other tools to further develop our fraud detection methods. And one example of a tool which we've built in-house is data ignition. So if you think about our traditional approaches to fraud detection, like red flag testing, which Thomas mentioned earlier, this can be quite limited, and an intelligent fraudster can, easily avoid hitting against these tests if they know what they're doing. As well as this, we've also seen that quite often it results in a lot of false positives, which requires a lot of, manual heavy review. So 3 years of investigating procurement fraud in particular, understanding the different fraud schemes and how a fraudster will implement those. This is or the development of our fraud detection platform, which is hosted on PwC's Data Ignition. So the platform is built to continuously monitor and detect fraud from major ERP systems by finding subtle patterns in the data that match known types of fraud. So how this works at a very high level, Data Ignition will first look to identify features, and these are the building blocks of fraudulent activity. So an example of a feature could be a vendor being paid into a bank account which is unexpected or unknown to the vendor, or a vendor's address being a PO box, for example. And then certain combinations of features will roll up into groups to form a fraud rule, or what we call an exception, such as vendor hijacking or false invoicing. And then these exceptions will then roll up further to form an overall profile of the vendors and the users within the system. So the results will then be collated and can be reviewed through various dashboards and charts within Data Ignition. And then workflows can be made which are customizable, like the screenshot shown here. So exceptions can be managed through workflows. They can be sent to individuals for review so they can investigate them and get to the bottom of what's gone wrong or why it's potentially being flagged. And users will get results and email alerts whenever there's new results ready for them to review. A user can then also tag transactions, such as tagging them as suspicious or fraudulent or low risk after they've done the review. And by adding tags to the transactions, this enables supervised machine learning to learn from the results and further automate the detection process in the future. So overall, the platform is built to continuously monitor, detect fraud as and when it happens, and this allows for proactive resolution and management through the workflows within the tool itself, rather than discovering that fraud has occurred, maybe months or years down the line. The next tool I'm going to talk about is process mining. So process mining as a whole aims to better understand and improve your processes by analysing the event logs which are output from company systems. So process mining software like Process Analyzer will take in these logs, which quite often can be quite complex, and it will transform this into a data flow which is easy to understand and visualize and interactive, like the example shown here. So a user can then drill into the data flows in a bit more detail. You can split it by, say, business unit or region, and this allows you to understand the common route that a transaction or a case will take and to explore any deviations. And this is good from an innovation standpoint. It allows clients to identify, maybe any unnecessary steps in a process or any steps which are causing bottlenecks, because it does time analysis. So you can see how long on average a case or a transaction will spend at each stage. And a key part of this then is conformance analysis. And this is essentially where you give the tool your sort of standard path or stages that you would expect a case to take. It will then compare all other cases against this and highlight any which don't conform to this path. You can then review these and you can see, how much they vary by and identify any potential risks. And so doing this can help also identify fraud risks, or maybe the pattern of events that have led up to a known fraud, which would allow the company to ask better questions, or maybe build in measures to prevent such activities from occurring again. And so if we just think back to the example that Fionnuala mentioned around inflating revenue prior to year end, so say process mining with conformance analysis had been used, and reviewed on a monthly basis by the company. At that point, it would have been identified that a large number of orders had, subsequently been returned and credit notes issued shortly after, which would have raised suspicions in comparison to other months previous. At this point, they probably would have been looked into further, and then in exploring the different attributes about those cases, it would have been identified that the orders were created in December, quickly returned in January, and a credit note issued shortly after. Also very likely that it was the same people who were responsible for, creating the orders and subsequently returning them. So ideally, it could have been caught sort of the first time round rather than letting it continue on and occur again in the following year. The next tool then I'm going to mention is Brainspace, and this is really good to gain insights and identify connections between unstructured data like emails and documents. So this allows you to explore the connections between your people, time, and concepts. And one of the key visualizations here is communication analysis, which you can see an image of, just the top image on the screen. And this essentially displays complete networks of communication between either like email data or instant messaging, for example. And this can be really useful at the start of the investigation to identify if you've got all the people in scope. And then as you start to explore it more, you maybe have your key suspects already for an investigation. You can start to, drill down and explore all the links. You can see who's been in communication with who, what information do they know, what periods of time have they been communicating in, how often do they communicate, and really start to, drill down and make your key network of your suspects. And a good example of this, if you think about an example in insider trading, so there's a acquisition or an accusation that during the time of an acquisition of a company, some insider trading was going on. So by looking at your key suspects, as you start to drill through, you maybe filter it down to the period of time just before the acquisition occurred to see who was saying what. And suddenly it's identified that there's 2 employees who have been communicating a lot more than they were previously, sharing a lot of information. And then as you start to drill into, the details of their emails, it's suddenly discovered that they are your key suspects. And this sort of leads into the cluster wheel, which is the bottom diagram. And so the cluster wheel will cluster your documents into key themes, and then there will be subclusters within each. So users can navigate the clusters and subclusters like a map and quickly identify neighborhoods of related documents. So this can also be helpful in identifying really what data you hold, and if you're potentially in, at risk of breaching any GDPR regulations as well. And one other cool piece about BrainSpace is the concept searching feature. And this is where you give BrainSpace either a piece of text or a paragraph or even an entire document as a basis, and it will pick out the key concepts from that document and apply the search across all other documents and pull you back anything that's related to those key concepts or themes. So this really goes a step far beyond your standard keyword searching, and quite often will bring you back documents that otherwise you wouldn't have found. So all of this really allows you to identify your relevant content far faster through the use of interactive visualizations, while reviewing far fewer documents in the investigation, and being able to identify links between people straight away. And so the last thing I'm going to touch on is natural language processing. So BrainSpace is largely built in this, but we can also use entity extraction to analyze text data. So NLP has the ability to differentiate between the meaning of data or the meaning of words, such as recognizing dove as a brand, as opposed to an animal or a bird, given the context of the document that it's in. Also has the ability to do sentiment analysis, so determine whether the tone of the piece of text is positive, negative, or neutral. And then some examples of where we can use entity extraction could be in identifying one-time vendors by looking at the entities in the invoice descriptions where maybe the vendor hasn't been populated in the vendor field name. Another example is in identifying potential duplicate payments. So if you look at just the example in the bottom of the slide, you can see that the details or the descriptions of the payments aren't exactly the same, so wouldn't be flagged up as a standard like matching exactly on the details, but by using entity extraction, it can be identified that they are relating to the same people and the entities match, therefore this would be flagged as a duplicate payment. Another example then could be in identifying fraudulent claims. So if you think about insurance applications, if you were to compare the descriptions of the applications against, all other claims in a database and pull out the key entities, you could find, different claims being made across different locations by different claimants, but the entities and the general description around the claims are the same, therefore potentially fraudulent. And then existing data can then be used to train your algorithms and evaluate the models, which overall will improve detection and decrease your manual effort in the long run. So those are just some of the key tools that we're currently using and developing to improve our fraud detection. But I'll now pass on to Stuart, who's going to talk about emerging technology.
Thank you, Natalie. So yeah, I think as a preface for this section, we've kind of talked about obviously red flag testing, and then how you take that one step further, and maybe layer in additional logic in order to refine your testing, and then how you build that in. I think in the past, on these types of investigations, whenever fraud or error has been detected, typically a lot of effort then goes into putting processes, etc., in place maybe to stop that, and then ultimately planning what to do with whoever perpetrated the fraud. And maybe one of the things that we didn't always capture was just that that information, labeling up that transaction as fraudulent per se. And now as data volumes grow and as more and more transactional data is being processed on a daily basis, actually we can start to really label up these fraudulent transactions, and then move away from sort of the hard-coded logic of red flags in the past, and go on to now training models to detect this types of fraud. Now it's still a difficult challenge. Obviously fraudulent transactions should be a very, very small proportion of those still seen within your transactional data. Certainly if you have 25% of your transactions are fraudulent, that is incredibly concerning. So, we're talking about, fractions of a percentage of things that we want to classify as fraudulent, but there are still some high frequency frauds that this can be applied to. And as Natalie touched on our data ignition platform, this has the capability to use logical rules to flag up fraud, and then once a client, for example, has reviewed enough transactions and tagged enough as maybe not even as fraudulent but concerning, we can then start to learn the indicators of what it is they're seeing, and start suggesting to the users, for example, that you might want to review this. It's low risk, it's medium risk, it is high risk. And then that really becomes powerful, because you can then start to step in between the transactions before they're actually paid. So for example, the machine learning algorithms can then say, hey, do not pay this transaction, block it because it looks high risk, until somebody reviews it and then releases it for payment. And obviously, this stuff all comes with the decision around, well, how many payments do you want to block? Because obviously, you need to be careful there. If you start blocking every payment coming out, your customers will become dissatisfied, for example. But certainly, for those that you're certainly confident they're high risk, this is a really good way of intervening before money leaves the door of your business. But there are lots of other ways we can use supervised learning, and it's even in the aiding of our investigations. So if you imagine somebody who's going through reviewing transactions, and they kind of navigate for a system, and they're looking at things, and you're sort of in the background, in their mind, they're joining the dots as to what they're looking for. But actually, you can look at the data that underpins each of the things that they're looking at, and start to, almost like Netflix does with movies that you enjoy, start to recommend new transactions and new information for them to review. And that certainly, it's got the same context and the same feel and vibe as the stuff that they are interested in looking at. Additionally, explainable AI, and explainable machine learning is sort of a new hot topic, and it's certainly removing the black box nature of a lot of this type of work. And if actually you can turn that on its head, and actually if you train your models to detect fraud, and you get to the point where they're really good, you can actually then get the model to explain, well, what is it actually looking at within the data that's telling you that this is fraud? And actually, in some way, you can almost learn those rules back, almost like a full 360 back to the start of the red flag testing. What are the hallmarks within the data that do that? I mean, there's obviously lots of other use cases we have. For example, image classification. As a team, we deal with lots of unstructured data as well, and whenever that comes in, sometimes you have images within there, but some of those images may contain text that can be OCR'd and extracted. Others, like pictures of cats, for example, you can't. And so efficiencies can be gained by doing image classification steps before you would put those documents into an OCR process, for example. So there's lots of interesting ways we can learn and progress from those logic based to machines actually detecting what fraud looks like. And then I guess as the next section I'll talk about is sort of the unsupervised approach. So still getting that labeled information, you may not have it, and it can take a long time to curate. So what can you do in the meantime? And I guess also, I mean, all of the techniques we've talked about to date rely on you knowing something about the fraud. So I always think about the situation of looking for fraud, sort of like looking for a needle in a haystack. But in our case previously, we know that we're looking for a metal needle, and we're going to apply lots of things that we know about metals. For example, if it's iron, or contains a high amount of iron, you could use a magnet to detect it, and that's kind of what these red flags and these scenarios are aiming to do. But if you don't know what the needle's made of, if you don't know what type of fraud it is, if it's a new type of fraud, for example, then how do you go about detecting that? And so, for example, one of the techniques you can use is anomaly detection, and that is the process of letting a machine look at all of the data, try to work out what's normal, and then obviously at the other extreme, try to work out what's really abnormal. And the idea is that if you've got fraud and error within your data, there's a high likelihood that it could render itself as an anomaly within the data, i.e. it looks really different from the standard transactions going through. Other methods we can use are clustering, for example, and that's just letting a machine group your data into subsets which are all in some sense very similar. And that can be useful if you've got a known type of fraud. It's something that's happened, but you're not really sure, like, what the underlying reasons for happening are, and you could actually, cluster your data, look for where that transaction, for example, lies within a cluster, and then question the cluster in general. Is there something specific about this? And other use cases might be, for example, in an ERP system, you might look at users and you might look at their activities. So, like, who do they usually interact with in a user approver type scenario? When, what time of day, what value, what vendors, etc. And you can start to cluster them together. And then if you get, in the example at the bottom right here, you can end up seeing all of these clusters popping out, but you might have small niches, and you might question, oh, what was this group up to? And actually you look at it and realize that they're all working together to raise and approve invoices for each other. And then maybe you go and look on down the line and there's payments, and actually it turns out that their bank accounts are on them. So it's just another way to do it. And so this is another option as well you could do, is you can now take sort of more deep learning techniques to cluster together sorts of descriptions and text fields, and then look for which ones are all similar, and therefore maybe help you review. And you can actually then start tagging these descriptions as, oh, these are all invoices, this is all credit memos, for example. And then you might end up looking at the other stuff that doesn't fall in the cluster and say, well, what are these outliers? These are the things that don't have anything else like them in the data. They're probably niche cases, and niches are really interesting things to look at, because they ultimately they could be error or they could be fraud. And I guess the last topic I wanted to touch on was around graphs. So if we could skip to the next slide. So I think graphs are something we've considered and we've worked with for a long time. And typically, when we talk about a graph, we're talking about nodes, which are like objects or entities, and edges, which are relationships between them. So you might think about users in a system, for example, and if you approve somebody's invoice, then you get a link. Or you might think about even just something like social media, and if you are friends with somebody on Facebook, then you join a line between the two. And then there's lots of interesting software and stuff that you can use to visualize what networks look like. But then there's the which is actually then mining that graph for further information. And so some of the things that we're looking at the minute are things to do with link prediction, which is training a machine learning model to predict the existence of a relationship in a potentially incomplete graph. So you might be thinking, you have lots of information about people who are related by some relationship, but you don't have all of the pieces of the puzzle. And actually what you want to do is use all of their connections to each other to infer the fact that two people are probably related, even if you don't have the piece of information that directly relates them. Node classification, which is sort of the equivalent to the link prediction, but for nodes, is the ability to then assign some sort of attributes to a node based on its position and place in the graph and its neighbors. So that might be saying if somebody is in a suspicious group, that they likely themselves are suspicious. And then community analysis, which is really the equivalent of the unsupervised clustering, but on a graph, and that's trying to identify similar subgraphs or subgroups within that graph. Again, a really interesting thing if you're looking at money laundering or something like that, and you want to say something like, oh, well, these businesses all look like shell companies, and you've clustered them all together. That can be very interesting for detecting where monies or funds are flowing into the net subgraphs or networks of money laundering. So I guess this is a whirlwind tour of, I guess, sort of the future that we see here for some of the techniques we can apply to fraud detection. But I think the overall keynote is that we use all of these things all of the time. So we still use red flag testing when it's appropriate. To do so, we use the the other technologies whenever the situations arise that we have rules-based testing, or we have a whistleblower allegation, and you know very, very precisely what it is you're looking for. But then we're also now more proactive in terms of trying to detect stuff that's maybe unseen or even unknown. And that wraps up, I guess, the topics I wanted to cover on. So I guess thank you very much to everybody who's listening, and obviously keen to answer any questions in the chat if there are any. So I think we do have.
Yep. What's the best practice advice should organizations adopt to undertake a fraud prevention process? So I guess this is going to completely depend on a couple of things, like number one being budget, obviously number two being your sort of technology stack, and three being your risk appetite. I think in the first instance, it's going to be working alongside, I would say, internal audit to understand where the risks sit within your organization. You want a really, really good grasp of your control environment and where that might be able to be subverted, and that's sort of where you start your testing. So, I mean, we've talked about the process from red flag testing down to the more advanced stuff, and I mean, if you were starting your journey, I mean, taking some of those risks and building out some of those simple red flag tests is the ideal place to start. And you build up your experience that way, and you build up a bit more business knowledge and get a bit nuanced as to where those holes and those gaps might be. And then sort of you take that to the next stage and you start to envisage, okay, well, it seems that we've done this test, we've identified this weakness, how can we take it further? How can we further tailor these tests? Stuart, anything else to add to that?
It's all about understanding like your greatest exposure point and your risk. If your business is, you know, high volume sort of business where you've got lots and lots of information going through, then it's very easy to hide stuff in that type of business. If it's low volume but high value, you know, you're going to take a different approach, and actually it's probably more about the review of those smaller items rather than, you know, large scale like testing and sampling.
Cool. No more questions that I can see. Okay, guys, thanks very much for your time. Session useful, and hope you enjoy the rest of Digital DNA. Thanks very much.